This is the first in a series of videos on distributions. And in these videos we focus on three concepts with distributions: shape, center, and spread. And this one we want to talk about shape. So first of all, let's think about what are some common distributions, right? Some common distributions that we'll talk about, and we'll talk about many, are one is the uniform distribution. Another one is the normal. In many ways, this is the workhorse of AP statistics. There's also the binomial and the geometric. And we'll deal with each of these in turn, and all of the concepts here that we talk about in terms of the shape of distribution can be talked about in terms of those. So when we talk about the shape of a distribution, the most common idea that we can think about is we can think about something that's called a probability histogram. And instead of thinking about it and calling it a probability histogram, sometimes it's called a PDF. A PDF stands for probability density function. And sometimes it's just called a density curve. So these are all just the synonyms for the same thing: a probability histogram, a PDF, or a density curve. And most common AP stats books use the term density curve. When you get on to more advanced statistics, they'll always talk about PDFs. The reason I use the term probability histogram is because it really talks about what we think about. So let's think about an example. And let's use as an example, let's say we roll a fair die. And let's say, for example, if you roll a 1, a 2, or a 3, then you get a score. Or if you want to, an X value of 10. And if you get a 4 or a 5, then you get a X value of 20. And if you get a 6, you get an X value of 30, right? So in some sense, the rows are simply to generate the probabilities. So if you think about the probability of X, the probability of getting a score of 10, since you get it when you roll a 1, 2, or 3, so that would be 50%, or 1/2. If you roll a 4 or a 5, that's 2 rows out of 6, so your probability is 1/3, or if you want to do it in decimal, 0.33 repeating. And rolling a 6 would be 1 out of 6. And 1 out of 6 is 0.16 repeating. And if we want to do a PDF or a density histogram, probability histogram here, then what we do is we would have, we can just do some graph paper real quick and write this up. We would just have a table or a histogram where along the x-axis will be the x value and along the y-axis would be the probability of x. So this would be defined as x. And this is the probability of X. In this case, in this particular problem that we either get a value of 10, 20, or 30. So let's do this. Let's do a graph of 10, 20, and 30. And let the height be the probability. So in this case, let's draw the graph here, right here. X, PX, that's 10 is 0.5, 20 is 0.3 repeating, and 30 is 0.16 repeating. 10, let's say 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6. Be careful on our axes. 10 would be 0.5. So let's draw this up. 0.5 is there. 20 is 0.33, so just beyond that. And 30 is 0.16, just about half that. And that's roughly what your PDF or density function looks like. Now, traditionally when we call it a density curve, it's a continuous instead of a histogram, but it's the same idea. Let's draw one that's continuous. If you think about a continuous density curve, then it might look something like this. Let this be x and this p of x. An example, let this be temperature, and this be the probability of a certain temperature. And let's do there. Let's have a mean here. Let's say the mean temperature on any given day is a 60. The key thing about the density curve is the area below the curve equal to 1. And the height is related to the probability of the outcome. And then the key here is, let's say we wanted to find the probability of being between 30 and 40 degrees in this case. So we write that the probability that x is between 30 and 40 is equal to the shaded area. And that's kind of the usefulness of a PDF, is it allows us to, for continuous variables, get a good sense of what the area below a curve is. And the density curve, if you think about it, just gives us the shape of the distribution. In the second part, we'll continue these ideas to talk more about the shape of a distribution.